If you take a look at these two images, which one feels more like the last few mornings? The one on the left is driven by high disconnection and burden, feeling isolated and under emotional pressure. The one on the right is high in fog, less clear thinking and more mental haze. Now the question is, can you trust images like this to say anything meaningful about your mental state? If instead of answering questions you had to choose between abstract images, left or right, could that reveal something interesting? That's what I wanted to test. I built a visual depression test, not to diagnose anyone of course, but to ask a simple question. If people choose between abstract images, do those choices contain any signal about depressive symptoms? And the surprising part is that one visual feature, fog, became much more important than I expected. And one feature I thought would matter a lot more, disconnection, barely helped. But before we get there, we need to talk about the most famous visual psychology test ever made. Just a quick pause before we move on. If you want to take the test yourself, you'll find the link in the description. Now, this is not a clinical test, but rather an experiment. There are 20 questions, and to answer them, you will have to choose between two images. I'd recommend finishing the video first because I explain how the test was designed and why. Once you're done, you'll get a scorecard showing your estimated depression score, how it compares with other participants, and which visual features were elevated for you. Now, back to the video. You've probably seen images from the Rorschach test before. It was developed by the Swiss psychiatrist Hermann Rorschach in the 1920s as a tool for diagnosing schizophrenia. And visually it's kind of brilliant. Dark symmetrical inkblots, strange shapes, enough ambiguity that your brain immediately tries to make sense of them. But scientifically the test became controversial, and for good reason. The problem was not that the images were useless by definition, the problem was that interpretation often depended too much on the examiner. Two clinicians could look at the same answer and not always agree on what it meant. And even when scoring systems became more standardized, it was still difficult to prove that results reliably predicted real clinical outcomes better than simpler tools. So the Rorschach test became this strange object, culturally iconic, visually fascinating, but scientifically controversial. It wasn't enough to say, this image feels meaningful. You had to show that interpretation was reliable, measurable, and actually connected to something real. But still, there is something appealing about it. Maybe it's just dark and artsy, which is why it appears in movies and TV shows so much. But maybe there is also something deeper here. Perhaps the issue was not the idea of using images, maybe the issue was the interpretation was too subjective. So I wanted to ask a slightly different question. Can we take the visual appeal of something like the Rorschach test, but make the interpretation more data-driven? Now, why would you even care about visualizing anxiety or depression? We already have clinically validated questionnaires. You can ask someone, was your sleep restless in the past week? Or was your appetite poor? Or for example, did you feel sad? And that works really well, so why bother with images? My gut feeling is that given how much humans rely on vision, it would be strange if there was absolutely no connection between how we see things and how we feel about them. We do not see the world in a perfectly literal way. A lot of what we see is prediction. Your brain is constantly guessing what is going to happen and updating the image of the world in real time. That is why when you are watching a fly, it can almost magically disappear for a moment. It makes a sharp turn and your brain fails to predict the movement in time. And the brain does a lot of heavy lifting under the hood. It doesn't ask you if you want to reconstruct old memories every time you remember something, but it does it anyways. So I find attempts to bring visual interpretation into the world of text-based psychological tests genuinely interesting. Not necessarily because visual tests are better, they're probably not, at least not yet, but because they may capture something slightly different. A questionnaire asks you to describe your state. A visual test asks you to recognize something that feels closer. And maybe that difference matters. So where do we start? Let's say we generate a bunch of images that we think should relate to depressive symptoms. They could be foggy, dark, heavy, isolated, empty, or even unsettling. Basically whatever seems visually close to how depressive symptoms might feel. But here is the problem. If I just decide what each image means, then I'm repeating the same mistake. I'm saying, this looks like burden, this looks like isolation, and this one looks like how energy feels. And maybe I'm right, but maybe I'm just projecting my own interpretation onto the image. So I needed a way for the data to correct me. The image could start with my assumptions, but they could not stay there forever. If people consistently chose the image in a different way, the meaning of the image had to move. That is where the model comes in, and I'll tell you more about this model in a minute, but first let's see how images were generated. I started by creating a latent vector that controls how the images look. It has 4 basic coordinates: depletion, having low energy, feeling drained; fog, experiencing unclear thinking and mental haze; disconnection, suffering from social isolation or distance; and finally burden, feeling emotional weight or pressure. At first, these coordinates are set manually, but later the model is allowed to adjust them slightly based on the data. The images were divided into 4 families. First, there are clear single-dimension images. For example, high fog images are more hazy and unclear, high burden images are darker, heavier, and have less open space. Second, there are 2-dimensional blends. These combine 2 coordinates at the same time. For example, you can feel both foggy and depleted, or disconnected and emotionally weighted down. Third, there are ambiguous images. These are intentionally less obvious. An image could feel dense but not necessarily burdened, or quiet but still emotionally pressing. And finally, there are control images. They exist to prevent cheap shortcuts, like darker images equal more depressed, because if the model only learns that, then it has not learned anything interesting. As you can see, I kept the visual style somewhat close to the Rorschach test. That part is definitely arbitrary. Different styles could work, some probably much better than others, but for this version I wanted something abstract enough so that people were not choosing obvious objects. Now comes the important part. How do we move away from arbitrary visuals to something more data-driven? That is where the statistics comes in, but before we jump into it, I want to take a small side note, and the question that I want to ask is as follows. Is it reasonable to approach psychological health in the same way we approach physical health? Can it be meaningfully analyzed using stats and math? I'll leave it hanging for now, but I'll revisit it at the very end. To make it more data-driven, I decided to align the visual test with a clinical screening questionnaire called CES-D. It's a widely used 20-item questionnaire for depressive symptoms over the past week. You get a score from 0 to 60, and statistically higher scores usually mean more severe depressive symptoms. So think about it this way: the CES-D is the grounded part. It's not perfect, but it's a real screening tool with research behind it. The visual test, on the other hand, starts as a weird experimental thing, so the goal is to connect them. Imagine a participant takes 2 tests. First the CES-D questionnaire, second the visual test, which has 20 questions. Each question shows 2 images, left and right, and the participant chooses just one. So for each participant we have their CES-D score, the 20 choices they made, the 40 images they saw, and the 4 coordinates behind each image: depletion, fog, disconnection, and burden. Now we can turn this into a prediction problem. Can we use the visual choices to predict the depression score? But more importantly, can we adjust the image coordinates in a way that makes them better aligned with both the choices and the depression scores? That is the key idea. We're not treating the original images as fixed. We're saying, these are our starting assumptions, now let the data correct them. Here is a simplified graph of the model. If you wanted to explore the model and the data more in depth, I'll leave the project link in the description. So the idea is simple. As was mentioned earlier, each image starts with 4 coordinates: depletion, fog, disconnection, and burden. At first, I set those coordinates manually, but then the model is allowed to adjust them slightly based on what people actually choose. The model itself is a dense neural network that aggregates trials into a 4-dimensional participant profile. It has 2 jobs. First, it tries to predict the person's CES-D score. That gives the visual space some connection to a real depression screening questionnaire. Second, it tries to reconstruct the choices people made In other words, given the participant's visual profile, can the model predict which image they selected, left or right? That second part matters because otherwise the model could become a black box. It may predict the depression score but for the wrong reasons. By forcing it to also explain the choices, the learned profile has to stay connected to the actual visual decisions people made. So the CES-D prediction gives the model clinical direction, and the choice reconstruction keeps it visually grounded. Together they create a stronger constraint. The model cannot just become a depression score machine, and it also cannot just become a visual taste model with no psychological meaning. In terms of performance, the model reached an out-of-sample R-square of around 33% and reconstructed choices with around 65% accuracy. This is not amazing, but for noisy psychometric data, it's not bad at all. It suggests that the choices were not random, there was some signal in the images. The initial images all shifted quite a lot after model training, which is not surprising. And when I looked at the learned visual profiles, one thing stood out. Fog, burden, and depletion were all higher in people who were more likely to be depressed. But this connection didn't help much in separating people with low and high depression scores. That was interesting because I expected this connection to matter more. There are a few possible explanations. One possibility is that the disconnection visuals were simply not good enough. Maybe I didn't represent isolation clearly. Maybe those images felt quiet, empty, or distant, but not specifically socially disconnected. Another possibility is that in this dataset, depression showed up more as an internal state, foggy thinking, low energy, and emotional weight, less as social distance. That doesn't mean disconnection is irrelevant to depression, it just means that in this version of the test it was not the strongest visual separator, and that actually makes some sense. Many core depression symptoms are about fatigue, concentration problems, sleep, appetite, and slowed down functioning. Social withdrawal can happen too, but it's more of a behavioral consequence than the central visual signal, and this is consistent with how an AMH describes core depression symptoms. The strongest signal was fog. People with higher depression scores selected foggy or hazy images much more often than the other types, so at least in this version of the model, the clearest visual expression of higher depression score was not isolation, it was mental haze, a blurred, slowed down, unclear state. Now, there are plenty of limitations here. The dataset should be bigger, the image generation system is only one possible version, the 4 coordinates are my own simplified framework, and this should definitely not be treated as a diagnostic tool. At best, it's just an experiment, a way to ask whether visual choices contain measurable information about depressive symptoms. But I think the bigger question is the one we put aside earlier. Can psychological states be measured in the same way we measure physical health? Can something subjective like sadness, fogginess, emotional weight be meaningfully analyzed with data and math? The honest answer is I don't know. Mental health is harder to measure than blood pressure or body temperature, and you can see that medicine got really good at treating physical illnesses, but when it comes to mental problems, that's where it's seriously lagging behind. So maybe visual tests will never replace questionnaires or clinical interviews, and they probably should not, but they might still reveal something useful, a way of seeing how people map internal states onto images, and for me that is the interesting part, testing whether subjective experience leaves measurable traces in visual choices. Once again, you can access the project files in the description, and I'm sure some of you could do a much better job at making this actually work. There is a lot more room for improvement, better images, better data, better modeling, and probably better questions as well. But as a first experiment, I think the result is interesting. And maybe somewhere between a questionnaire and an Inkblot, there is a more data-driven way to visualize how people feel.